Okay, so hello everyone. I'm Vrany. I'm working on this Smalltalk as well, and I work on other Smalltalks too. And today I'm going to talk about debugging. Right? It's interesting because before we saw some crashes that should be solved and should be debugged. And now I'm going to talk about the debugging. Okay, before we start, let's just make a, let me just ask you a few questions just to know, what is the state of the audience. So, who of you do program? Good, that was expected. Who of you do debug programs? Okay. Yeah, there are a few people, not me, right? Without debugger, I would be lost. Now, who of you enjoy debugging? Still, good number. Okay, who of you debug hard stuff? And now, what is the hard stuff? For example, you call FFI and the whole VM or runtime or environment, however you want to call it, just crash. Disappear, like it happened to Portugal. Right? Who does that?
The question is who uses debugger to do that, or who has to fight with those problems?
No, who debug problems like this? So who has to fight these problems?
Yes.
Well, significantly less people. Now, who?
So your talk is only for those people?
No, not really. No. The most important question now is who enjoy debugging this hard stuff. Yeah. Well. Yeah. Valeria too, but that's a special case. Okay. What I'm going now to show you is how to debug the hard stuff. And what I'm trying to demonstrate is that it can be actually quite fun if you know what you are doing. And it can be even as easy and as pleasant as debugging a normal Smalltalk code in a Smalltalk debugger. Let me try. Maybe for me it was like it's as easy, but yeah, I've been doing this for years, so I'm biased. But let me try. When I thought about this talk, I was like, okay, I will show you how to do these things and what are the pieces. But then I realized that this might be a little bit boring or dry or maybe not as interesting. So I decided to show you the debugging session. So if you agree, we are going to debug hard stuff. Well, it depends what's hard. Segmentation faults and stack smashing and things. That is hard for me. That I consider hard. Hard enough. Okay, so what we are going to do is to debug this case. So one day, this just landed on issue tracker. My friend was just complaining that the stuff just crashed. Right? So this is a real case. This is not a example I made for the demo. This is what really happened. So this is the screenshot of the real bug report. And so what happens? Something goes wrong, and the whole system just crashed. Now, the friend of mine filed in, he's very good on isolating the test case that demonstrates the crash. So this is usually the hardest part. But he did that, so that makes my life easier. But if you look what it does, it creates a Unicode 16 string. Well, it's a bit convoluted code. You don't really need it, because you override it as a literal. This is some Japanese sentence. I don't really know what is it saying. I hope it's not anything offensive. My friend knows Japanese, so he might be able to tell. But anyway, it doesn't matter. Just a string. And then you just concatenate the string with itself 200 times. Oh, obviously, this is a bit silly code. I mean, there is no way this code is not going to crash. So sooner or later, you will exhaust your memory. You know, perhaps at, I don't know, 25, 26 iterations, and you're gonna crash. But what happened is that it didn't crash, saying like, you know, exhausting all memory, something like that. It just crashed. I mean, segmentation violation. So this is something we don't want. You know, it should at least tell you, sorry, there is no memory or something meaningful. So let's go into debug it. So this is how I'm tackling these problems, right? The first, those are actually three very simple steps. So first of all, you have to create some script so you can demonstrate the issue. So this is essentially copy-pasting the stuff from the bug report to file. And then you run it. We run it with, well, let's actually run it. Much better. Because it takes some time. Okay, so what I do, there are some debug breaks and things like that. So what I do, I run the whole system, you know, the case. But if you recall, there are these funny things where we are. Yeah, record. This is interesting because I run the system in a way that this execution is recorded on a system level. I mean, on a single CPU instruction level. This is a great because then, as you can imagine, I can replay the execution. So I get exactly the same thing. This is very important because you see it takes quite a long time to run, and even though computer is deterministic, the execution, given all the hashing and things like that, it's not that deterministic as you would like.
So you are recording the instructions that is executed.
There is some certain sort of magic, but the effect is that you have recorded the whole execution on the instruction level granularity. So you can simulate on the instruction level the. So we are talking about these mocks and calls and things like that.
And that the tool that lets you do that is not part of the system, right? It's an external tool.
Yeah, it's external tool. It's outside the. Then we have this, abort and segmentation violation because that's merely a technical thing. Because in SPX, if you get a segmentation violation, the VM catches it and gives you a Smalltalk debugger. We don't want to crash it. Well, now it takes time because it actually crashes once the heap exhausts, I don't know, 6 gigabytes. But you see, it's copying and creating, and this is quite a pathological and very stressful situation for the GC, because the GC tries to find a space, but we are doubling the amount of data, so it's bound not to find a space, and that's a pathological case. That takes time. Okay, we crashed. Good. So at least we crashed. That's not always I'm so happy that it crashed, but by the purpose of this talk, it should have crashed, and it did. Okay, now the more interesting part is that we are going to debug. So we run the same, Smalltalk, and we say we are going to replay the last recorded execution. This is what we have just done, and this is just run it under VTP, which is a little tool I brought on top of the debugging stuff. So let's do it. Here we go. So this is the debugger, right? It's a little UI tool, nothing really too fancy. And now, if we start it in that way, it actually stops the recorded execution, or at the very beginning. So this is just before the first instruction is being executed. So naturally, we don't know what is the nature of the problem, so the first thing is we just run it to see where it crashed. So let me do that resume thing. Okay, now it's running and replaying. So now it's going to take another couple minutes, because now it's essentially doing the same thing we recorded just before, but taking the data, actually simulating the execution from the recorded. That's the effect of it. So yeah, it's gonna take.
Why didn't you just execute it the first time with the debugger? What do you need to do?
I could have, but then, the thing is, when you're debugging, then the problem is, then you do something in the debugger, and you realize, okay, I should have looked to something else, but it's already too late. And then you run it again, and it doesn't crash. I mean, in this case, it would crash, but if it's some sort of race condition, depending on timing because of I/O interrupts, you see this sort of problem. So for me, the important thing, or the useful thing, is that I have a repeatable execution. So I can debug over and over and over, having exactly the same behavior, crashing at exactly the same method. The memory layout is exactly the same, because in model kernels you have this, address space randomization. So every time your heap is somewhere else, and then you cannot make sense of pointers, and this sort of thing. This makes this repeatable and reproducible.
John?
Oh, perfect.
So where is that stored? It's a file?
Yeah, it's somewhere on the disk.
It's a file that you're going to take it tomorrow?
Yeah, indeed.
Do this?
Yeah, indeed.
I'm sending to people who give me support.
Yeah.
Coming from somewhere, right?
Yeah.
Okay, we crashed. Good. So now, well, I had to make the fonts big enough, and obviously then not much is fitting in the screen. But what we see here is a stack. So it crashed somewhere in a underscore lookup. That's an internal VM routine implementing the message lookup. Well, I don't want to go into the details. This is described in a paper what this exactly does, but that's not important. The interesting thing is that here we have a stack, and as you see, we here see some sends, which are the VM routines for implementing a message send. So whenever the inline cache or polymorphic inline cache fails, you fall back into the send that does the lookup, a few other checks, this and that, and finally calls the code of the looked up method. But here we see a Smalltalk code, right? So this is a C code of the VM, a C code, and here we see the Smalltalk code, pretty much. Right? So here we have a connection between the Smalltalk stack and the C native stack. If you would be calling some FFI, you would see the Smalltalk frames, and then the FFI C frames for whatever we are calling. So this itself gives you a very good overview, or very good image of how you get, what Smalltalk code get executed. You can do much more. For example, if I don't know, send. Okay, so here you see a selector, right? So now we see this is a selector which is sort of. You can even inspect it. So yeah, this is how the selector looks in internal. So here there's the object header, and there are some slots. We can go inside the class, and this is what makes the class. So you see, the Smalltalk image is completely dead. It did crash with a segmentation violation, but we still have an inspector like we have in Smalltalk. right? And we can inspect objects and see what's going on there. But at the same level, we can see, for example, the instructions or memory dumps or things like that. So if you click here, you will see, the machine code. So you have the connection from the very low level to the very high level at the same time in a single tool. That makes, I hope you agree that it would make things easier to reason about. Okay, so if we go and debug where we are here. So, well, we have to. Well, I forgot to say that I understand this might be a little rough for people that are not really used to, C assembly and memory dump. But if there is anything you don't understand, just ask. Right? Few of you do that. I'm very grateful. But I just make sure that I would welcome any question. So anytime. All right. Yeah. Big mistake. Now I see.
How you are, at this point in time in the debugger, you would be on the loop 25, 26 of the iteration that would...
Yeah, perhaps something like that.
Yeah. How you are able to inspect and not get out of memory? You were already too close to get out of memory.
Well, the thing is, the Smalltalk is dead. So the whole thing, I'm just reifying what is in the memory. I'm reading the memory and reifying the object.
From a file.
No, well, yeah, kind of from a file. Kind of. Yeah. The technical solution, I will outline it how it's how it's all done on technical a little later. But I just want to give you the picture. What is the result? What you perceive once you get all these pieces together. Because this is what you want. How it's done, that's a different question. More complicated question. So let's debug it. We have segmentation violation on this line, so perhaps that's because we are referencing current class. And if you see current class is, the value is quite funny. Right? This is probably not a valid loop. I mean, it could be, but it's not. I know enough about the internals that I know that this is really fishy value. And you see, even the tool tells me, the red thing tells me, there is something fishy about it. And if you scroll, then it will even tell you, well, it doesn't, cannot read the memory. So it tells me this is wrong. So the tool kind of attracts me attention on one. Little thing, but very helpful. So this is because this is fishy. So well, how we get this value? From where the value come from? Probably an educated guess. Probably, the code might have been written in a nicer way. But anyway, we have this cell. And if, again, let's see if this will show something. Okay, I don't know if you can read it, but it tells me, okay, the OOP is this one, but its class is invalid. So I cannot tell you what is it, because it's invalid. And this is the same value as we've seen before, so it comes from asking the self-object, this guy, for its class. So now, what happened is someone just smashed the object, brought to its class field something that is nonsense. Okay, that's very bad situation to be if you are debugging these things, because this is a consequence of some bug, some problem that happened before. Long time before, possibly, and the GC just didn't trigger, so we didn't it didn't manifest. Well, how to debug this? It happened in the past. But if you think if you think about what you really need to do, how to get to the point, then it's relatively easy, right? Because you just what you want to do is to set up a watch point on a certain memory cell and look in who overwrote it. But it happened in the past. So now the trick is, because we have the record, we can go backward in time. So the strategy is very simple. We just set the watch point to see how, who's and when smashed the particular memory chunk that holds the class pointer. And that's the victim, and then we can continue debugging. But we certainly need to know who did that, and then continue reasoning. Okay, so again, it shouldn't be that difficult. Setting the watch point, well, that's very easy. So now we have a watch point, and all we have to do is just to go backward in time. Easy. We just press reverse and wait until the debugger stops on the watch point. Now, it's going to take a while.
That will give you the last time.
Sorry?
You are going reverse, so it will give you the last time.
Yeah, the last time someone smashed it.
Maybe it was just once, so it's the first time also.
Yeah. But I mean, I don't know where's the bug. So maybe it happened not the last time it was changed, but even before. But we don't know until we get to the point. So we need to find where it happened.
So, sorry, what does the reverse strategy do?
So normally, if you execute,
yeah.
So you have the sequence of instructions. So you go from the top to the bottom.
Yeah.
Blah 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 blah.
Yeah.
And the reverse does actually the same. So it undoes the effect of the instruction in reverse order.
Okay.
So you go backward in time.
Okay.
And because
Okay, muy poquito.
I mean it's simple now. You just go backward in time.
So I'm trying to figure out how it does it. I understand why it does it.
How it does it?
How it does it?
That's a different story.
Okay.
That's a completely different story.
That's right.
All right.
Okay.
But once you have something that can do it, everything seems to be simple. Huh? That's the point of it. Obviously, this is stopped. Perfect. So now we are the code that smashed the value, and now we can reason about it. I have very few minutes, and I want to have something for questions. So now, if you look at the code, well, this is going to be really, really rough for someone who is not a hardcore C programmer. But yeah, there is some sort of pointer arithmetic, and if you look at the code, there's a plain line. You would immediately see that this is an integer overflow. So what happened that you copy the stuff and you calculate the pointer where to put the character when you're containing stuff, and the pointer overflow. So instead of adding the index, you add the negative index to the object header to get to the point. So you get a complete random chunk and smashed overwrote some other object.
But that means that the pointer is smaller than the memory. Because it's overflow. What overflow is a pointer.
Yeah, that's the thing, you see there's this unsigned, but we are on 64-bit. So this is a 32-bit unsigned, but we have to use, that's what I said, if you know a little bit, then you will figure out. I don't have the time to show you all the code, but let's assume that for me, once I get there, it was immediately, in the next two minutes, I fixed that because instead of unsigned, I put unsigned integer pointer and immediately fix it.
So this means that this is a 64-bit Smalltalk.
This is a 64-bit Smalltalk.
But objects can be up to 4 gigabytes, right?
Objects can be up to 1 whatever is 64-bit power of 2. 64 power.
But you have something that is articulated.
Well, that's the problem because someone never saw that this code would run on 64-bit. That's a bug.
That's the bug.
That's the bug. We should have used a 64-bit unsigned integer instead of 32-bit unsigned integer. However, if you write unsigned in a C, you never know how wide it's going to be. It's a bug. This is the bug. But we are going deep into C. I don't want to go there. So that's the thing. And here we go. That's why I wanted to record, so I can go backwards.
Okay.
And now we can see the assembly and things, and we can go backwards, forwards.
Yeah.
Well, it speeds up the whole process a lot.
Yeah.
I mean, really, now it takes me half an hour to fix it with explanation. I think from taking the example, the case, the test case, to committing the fix, it took me like 10-15 minutes with all this tooling. Okay, I hope it was convincing. Now a little of what needs to be done, or what are the pieces which are in all this tooling. So first thing, you need a GDB, a good old GDB. Then other thing is a bit of a Python. I see your faces, faces. Python's fine. I can tell you, Python's just fine. GDB works fine with Python. I use Python. I don't care that much. Then you need a VDB. That's the nice UI interface that helps a lot to see. You see more things at once. I have two large LCDs on my desk, so I see all those things at the same time. And then there is a RR, which is the record and replay framework implemented by Robert McCallahan from Mozilla. If you ask me, if RR is the only single thing that Mozilla did, it's worth it. Yeah. It's a great tool. And really, all I did, I didn't implement anything special or did anything special. I just look around and take stuff. And this emerged. Okay. Here is the stuff if you want to play with it. If you have questions, I'll be more than happy to answer.
One question. We can need to add much support for this tooling inside Smalltalk.
No, not at all. Well, there is a one little bit that I added, but it's also used by the Smalltalk itself. And I just realized, okay, but if I use it also in this tool, it would make it a little bit more pleasant. So it's not like that is a special support, but it's a kind of support that I also use. Obviously, you have this. Normally you don't have a dwarf metadata for JIT code. I do, so that helped a lot. But even if you don't have a dwarf metadata, you can get away. But it's more work to reify things on the system level. But most of the, really, I use this tooling, this RR, if I'm debugging GDB or if I'm debugging B, I use the same tooling. For sure. That's not. I'm pretty convinced that this is not something specific. You might want to, or you might have to do more work because, for example, stack unwinding is for free if you are using a native C API, but most Smalltalk don't. So you have to write your own stack unwinder, which I didn't because I used the SDX used the native API. But other than that, I'm pretty sure it's doable, and I use it for B already. Any other question?
Yes, and the reverse execution, is it used in another, let's say, high-level language to debug in the reverse order. So use that facility you have at the assembly level.
Well, the record and replay framework is fairly generic. You know, it doesn't know that this record is Smalltalk at all.
I know, but using that, it would be possible to have a reversing of Smalltalk stack without looking at all the details in the native code.
Yeah, for sure. I mean, well, I killed. Oh no, I didn't. But I mean, if you look here, you see, well, you see the runtime frames mixed with the Smalltalk frames. But I mean, in the tool, I can just make an option to hide all the runtime frames, and suddenly you will see exactly the same stack. You know, the same list as you see in the Smalltalk.
My question is there any high-level language, programming language that uses this facility to provide at the language level debugging or reverse debugging at the language level? Or could we do that in Smalltalk? I see what you say, right? So, is done?
Well, it is used. I mean, depends. I don't know about the tooling, but for example, I've seen this, you know, verification of the stack for Java, you know, for the hotspot thing. Obviously, for Mozilla SpiderMonkey JavaScript engine, they use it naturally because, you know, it's a Mozilla project. So yeah, it's clearly possible, and people do that. Okay, then that's all.